Science is getting weirder every day. Modern physics does give us answers to the mysteries of the universe, but it raises a lot of new questions along with it. Now, a new research published this year proposes that there may be another anti-universe, where time runs backward prior to the Big Bang. Can we somehow interact with this anti-universe? What exactly goes on in there? Today, we will look into this new research study that tries to understand the dark matter in our universe according to the multiverse approach and states the existence of an anti-universe.
Things just got out of hand.
My name is Siddharth and you are watching The World of Science. So how did the universe begin? You might think of the Big Bang, but the answer is not that easy. There are different proposals other than the Big Bang, such as Cyclic Conformal Cosmology by Roger Penrose, mirror symmetry model of string theory, big bounce theory of loop quantum gravity, and so on. What to believe then? The mathematics support different possibilities, and thus the study of the origin and fate of the universe, dark matter, dark energy, etc. is still a wide open area. The idea of a multiverse originated in the latter part of the 20th century to explain some discrepancies found in the current model of the universe. The multiverse proposes a different possibility for the structure of the cosmos, and one such possibility is for the understanding of the nature of dark matter. Now, a new research proposes that there may be another anti-universe running backward in time before the Big Bang. The concept of antimatter and anti-universe is more mathematical rather than physical. Classical and relativistic physics allow time parameters to take both positive and negative values, meaning theoretically time like space is bidirectional. In this case, future and past have the equal possibility in theoretical calculations. In classical physics, which we generally do in colleges, a negative value is simply ignored, whereas in relativity, this is the foundational basis. Time and space coordinates are not treated as separated, but as interwoven four-dimensional fabrics in which both coordinates behave differently depending on the observer and its motion. When we think from this perspective, Big Bang does not look like an absolute origin point but a 0 point on the axis of time. At its right is the forward-moving time axis that represents our universe, and at its left is the backward-moving time axis, which can be called as anti-universe. Now let's talk about dark matter. The concept was first discussed in the 1930s when scientists observed some anomalies in the spiral galaxies. Apparently, the speed of bodies in the outer arm of galaxies was more than what calculations predicted. To have such speed, there must be a greater presence of mass throughout the galaxies, but scientists knew that most of the mass of a galaxy is concentrated in its center, which is called active galactic nuclei. If that is the case, it was proposed that there must be some invisible source of mass, which means some invisible matter which does not interact electromagnetically but must be massive enough to exert influence on other particles. This matter was named dark matter. More recently, the prime candidate for dark matter is called weak interacting massive particles, or WIMP. Everyone is searching for this mysterious particle, but none to claim success. And this is where we come to this new research that is proposing a different approach to unravel the mystery of dark matter. The study was done by Latham Boyle and his team from the Perimeter Institute of Theoretical Physics, Canada, and the University of Manchester. It assumes that there may be another universe with time running back from the Big Bang point, and if that is the possibility, then dark matter, which is so mysterious, is just a new flavor or variant of the known particle, a neutrino, that can only exist in this kind of universe. They constructed a model of CPT invariant vacuum on a background of a homogeneous isotropic and expanding universe with time reversal symmetry. We have explained CPT symmetry and its violation in this video. Do check it out later. CPT stands for charge, parity, and time. This is a combination of fundamental symmetries in nature. If you flip the charge of all particles or take a mirror image of a certain interaction and then run the interaction backward in time, there should be no change in the structure of the particle interaction. It will look the same, but particles can violate one or two of these symmetries at a certain time and in certain interactions. But there has not been a single observation of violation of combining all three symmetries at the same time. Theoretically, all the interactions happening in nature will behave the same if we flip the charges, take the mirror image, or run the interaction backward. Now here comes the interesting part. If CPT symmetry is absolute, then instead of applying it only to individual interaction, we can apply this symmetry to the entire universe itself. If this universe preserves the CPT symmetry, then there is a possibility that to preserve this symmetry, another universe may exist where the charges of every particle are flipped and time runs backward. This other universe will be the mirror image of our universe, and the reference point between these two universes will be the point we know as the Big Bang. But how can we know this theory is correct? What are the implications of this theory? Well, this CPT invariant universe gives many new possibilities. If this universe is fully CPT invariant, then it must ensure that there should be CPT invariance between all the particles and interactions. Now here, we must know something about neutrinos. Neutrinos are subatomic particles similar to electrons but with no electrical charge and very little mass. Despite being one of the most abundant particles in the universe, they are very difficult to detect. Every particle comes up with some quantum properties. One such property is known as chirality or handedness of the particle. Depending upon the spin of particles, a particle may be left-handed or right-handed. A particle is right-handed if the direction of its spin is the same as the direction of its motion, otherwise it is left-handed. All neutrinos are known only to have left-handedness, and this is one of the unsolved problems among the physicists, that why there is no right-handed variant of neutrino. This new research tries to solve this issue. For a CPT invariant universe, there must be a right-handed flavor of neutrino to preserve the symmetry. This right-handed neutrino only interacts via gravity. If this flavor is proven to exist, then it can account neatly for the observed dark matter in the universe. To conclude, this universe is the CPT reflection of another universe that was present just before the Big Bang. These two universes can be seen as a universe-anti-universe pair that must preserve symmetry and produce a right-handed flavor of neutrino, which in abundance will act exactly like our dark matter particles. All this is from solutions to complex mathematical problems. We build models, define the variables, define the boundary conditions, propose a hypothesis, and try to find an appropriate solution, and eventually we do get a solution. Sometimes it is similar to our perception of reality, sometimes it's totally different. Swedish-American cosmologist Max Tegmark's model of the mathematical universe says that as per one interpretation, the universe is not just well described by mathematics, but it is mathematics. All possible mathematical structures must have a physical existence and collectively give a multiverse that includes all others. This is the beauty of the cosmos. It is full of infinite possibilities, so it shows its different forms in different symmetry, different equations, and a different model. So what are your thoughts about this new research and the existence of an anti-universe possibly full of antimatter and running backward in time? Let us know in the comments. If you found this video interesting, please leave a thumbs up and share it with your friends. Check out the latest issue of our magazine Cosmos Now, which is India's first independent astronomy magazine. Link is in the description. Do follow us on Instagram for daily quality content that'll make you fall in love with science. Make sure you subscribe to the World of Science. Until next time, stay scientific.